Once again, welcome back to the video series Max Revision Made Meticulous, Topic Integral, Day 18, Properties of Definite Integral. In this video, we will see one of the properties of definite integral and problem based on that. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us now take one of the properties of definite integral. Suppose you have a number c lie between a and b. A is the lower limit and b is the upper limit. If there is any real number lies between a and b, we can split the integral a to b f of x dx as integral a to c f of x dx plus integral c to b f of x dx. Here which we have to be very careful, two things, that is c lies between a and b, and the upper limit of the first should be equal to the lower limit of the second. Suppose I take 1 to 4 f of x dx, I can split in any place in between 1 and 4. Let me split at 3, 1 to 3 f of x plus 3 to 4 f of x. Once again, this 1 to 3 can be written as 1 to 2 plus 2 to 3 and again plus 3 to 4. Now again, once again, this 1 to 2 can be split as 1 to 1.5 and 1.5 to 2 like that. It is lefty. Now normally, this property is used when f of x is different for different values of x. Where we will have this f of x is different for different values of x, we will see in problems now. Let us take this problem now where f of x is defined for less than 0 as 1 minus 2x and for greater than 0 as 1 plus 2x. But they want the integration from minus 1 to 1. Therefore, we have to split the integral at 0 because at 0 only the function is defined differently. Therefore, it should be from minus 1 to 0 and 0 to 1. And from the given definition, from minus 1 to 0 it is 1 minus 2x and from 0 to 1 it is 1 plus 2x. Therefore, put it there now. The integration of 1 is x, integration of 2x is x square by 2 into 2, therefore it is x square. In the second integral, integration of x is 1 and integration of x is x square by 2, 2 getting cancelled. Now when I put the upper limit minus lower limit, upper limit is 0, lower limit is minus 1, therefore minus 1, therefore minus 2. For the second term, it is upper limit is 1 plus 1, lower limit is 0. Therefore, the final answer is 4. Here we have done a problem where f of x is defined for less than 0 and greater than 0. At the place where it is defined, we are splitting the integral using the property and we are applying the value of f of x and then integrating. Now this all of you know what is this function. This is a greatest integer function. What is the specialty of greatest integer function? Whatever the value, real number value you give, the final answer, the outcome or the image will be an integer less than the given real number. It will be an integer less than the real number. For example, for 0 to 1, the value of this greatest integer function will be 0. For 1 to 2, it will be 1. For 2 to 3, it will be 2. Therefore, I can visualize this as it will be 0 for all the values lying between 0 and 1. It will be 1 for all the values lying between 1 and 2. It will be 2 for all the values lying between 2 and 3. For I have to split the integral at two places, that is 0 to 1, 1 to 2 and 2 to 3. Suppose if it is 0 to 4 given, then again you will have one more, that's 3 to 4. Well, now what is the value of this greatest integer function at the first integral, that is 0 to 1, it is 0. For the second integral for 1 to 2 it is 1. For the third integral it is 2. First integral no need to do because it is 0. Second integral is x from 1 to 2 and second one is 2x from 2 to 3. But when I substitute the value, that is upper limit minus lower limit, the final answer is 3. But like this you can do the integration of greatest integer function like this. But now we have seen how this property is useful for greatest integer function. Then how this property is useful for a function f of x which is defined for some values for x greater than 1, less than 1 or lying between 1 and 2 like that. Let us go to the very important application of this property, that is to evaluate integral a to b modulus f of x. That is, if a function is given inside a modulus. All of you know, when a function is defined inside a modulus, it will behave in a way that based on whether that f of x is greater than 0 or less than 0. How to do? You have to solve f of x is equal to 0 and get the values of x and split the integral a to b at these points and identify the sign of f of x. That is why we were discussing now. The sign of f of x will be either negative or positive based on the value of x. Evaluate the integral and apply the limits. Very simple. Whatever there inside the modulus equated to 0, get the values of x, split the integral at this point and then identify that modulus of f of x, whether it is minus of something or simply the same thing. Let us go to this problem now. Integral minus 5 to 5 mod x minus 2 dx. What you have to do? Put x minus 2 is equal to 0. You will get x is equal to 2. But we have to split at 2. Now why we are splitting at 2? Because mod x minus 2 will be minus of x minus 2 for minus 5 to 2 and it will be x minus 2 from 2 to 5. Why this minus of something? Because mod x minus 2 will be negative from minus 5 to 2. To make as modulus, we are multiplying it by minus, because minus into minus will become plus. Already you have seen it in class 11. What is the meaning of mod x? It will be minus x for x less than 0 and for x it will be for x greater than 0. Well, therefore we have to split the integral at 2 minus 5 to 2 of modulus plus 2 to 5 of the modulus. But from minus 2 to 5 it is minus of x minus 2. From 2 to 5 it is simply x minus 2. Now do the integration. Now for my convenience, minus of x minus 2 I am writing it as 2 minus x. You can take the minus sign outside also, no issue. Now how to integrate? The integration of the first one is 2x, second is x square by 2. Once again for x minus 2 integration, x square by 2 minus 2x. Let us continue. Now we have to put the upper limit minus lower limit. I have put it now. Upper limit when you put the first term 4 minus 4 by 2. Lower limit when you put, it will be minus 10 minus 25 by 2. In the same thing, in the second one by x square by 2 minus 2x, when you put the upper limit 5, it will be 25 by 2 minus 10 minus of, when you put the lower limit, it will be 4 by 2 minus 4. Now we will simplify it. It will first quadrant 0 to pi by 2, it is positive. In the second quadrant pi by 2 to pi, it is negative. First split it at pi by 2 now. For 0 to pi by 2 mod cos x plus pi by 2 to pi mod cos x. So it will be 0 to pi by 2 cos x plus pi by 2 to pi minus cos x. Integration of cos x is sign. Once again integration of cos x is sign. I have brought the minus sign inside. Where it will be sin pi by 2 minus sin 0 minus of sin pi minus sin pi by 2. Sin 0 is 0. Sin pi is also 0. You know the value of sin pi by 2. Therefore 1 minus of minus 1. So the answer is 2. Similarly, when they give modulus of any other thing, any trigonometry function, you can identify that based on the quadrant in which it lies. All of you know what is the nature of sin x, what is the nature of cos x, what is the nature of tan x in the quadrants. Based on that, you can split it and you can get the value of it. Good. Now let us go to another problem where it is x cube minus x, mod of x cube minus x. Now already we have split the integral only into 2 in most of the cases. Here let us apply the same idea. I will equate x cube minus x to 0. I will get x into x square minus 1 is equal to 0. X into x plus 1 into x minus 1 is equal to 0. The value of x is minus 1, 0, 1. What is the speciality now? We have to split the integral from minus 1 to 0, 0 to 1 and 1 to 2. Let us identify from minus 1 to 0, this x cube minus x will be positive because you are having 3 brackets. For x is negative and x minus 1 is negative and x plus 1 is positive. Therefore, it will be minus into plus. Therefore, it is positive. Similarly, from 0 to 1, it will be a minus of x cube minus x, and from 1 to 2, it will be x cube minus x only. Based on the nature of x, we are identifying the value of this function, whether it is positive or negative. Well, now split the integral into 3, minus 1 to 0, 0 to 1 and 1 to 2. Already we have identified from minus 1 to 0, it is x cube minus x. From 0 to 1, it is minus of x cube minus x. From 1 to 2, it is x cube minus x. Let us continue. Normal integration, x cube minus x is x power 4 by 4, x is x square by 2. We have done it in all the brackets, and only the thing is, even though the integration is the same, the only thing is the limit changes. If you apply the upper limit minus lower limit for all the term, first term 0 minus of 1 by 4 minus 1 by 2. Second term I have taken minus sign outside, 1 by 4 minus 1 by 2 minus 0. Third one plus of 16 by 4 minus 4 by 2 minus of 1 by 4 minus 1 by 2. I am collecting all minus 1 by 4 at one place, minus 1 minus of minus 1 by 4 minus of minus 1 by 4, 4 minus 2 minus of minus 1 by 4. 1 by 4 is added 3 times, therefore it is 3 by 4. 4 minus 2 is 2, therefore the final answer is 11 by 4. Here what is the speciality of this problem? This problem you have been given a cubic polynomial inside. For when you equate it to 0, you will get 3 values of x. We are splitting it at 3, and even when you are splitting it the integral into 3, the value of x minus x is negative in the positive in the first, negative in the next, and positive in the first. Therefore you have to identify whatever inside the modulus, whether it is positive or negative, then you have to put it, then do the integration. Success is dependent on efforts. All the best. Thank you.